Warm up. Use a graphing calculator to find all points of discontinuity. And the points that we're interested in is where the denominator is 0. So let's plug in the denominator into the calculator. We have x to the third plus 2x squared minus 9x minus 18. And we'll go zoom 6, and we'll see where this graph is crossing the x-axis. So at -3, -2, and 3. So x equals -3, -2, and 3. That means the denominator has factors x plus 3, x plus 2, and x minus 3. The numerator has x plus 2 and x minus 1. So we see we have a hole at x plus 2, and we have infinite discontinuities or vertical asymptotes at 3 and -3. Determine where each function is increasing and decreasing. Also give any absolute or relative maximums or minimums. Round to the nearest hundredth, round to the hundredth if necessary. So let's put that into the calculator. We'll clear this out. X to the third minus 3x squared minus 6x plus 8. Let's graph this. And we're not quite high enough, we're not quite low enough, but I don't think that's really going to matter. Second, calculate. I see we have a maximum. Let's go to the left of the maximum and to the right of the maximum, and we'll guess right there. That point is -0.73 and 10.39. Then we should have another point for the minimum. Second, calculate. Number 3 is a minimum. So we need to click over to the right. There's to the left bound. I need to get to the right side. There's to the right side. And to the guess. 2.73 and -10.39. So this function is increasing from -infinity to -0.73. Then it decreases from -0.73 to 2.73. And then it increases again from 2.73 to infinity. So that's increasing, decreasing. Also give any absolute or relative maximum. We have a local or relative, same thing. Local max of 10.39 at -0.73, at x equals -0.73, and a local minimum of -10.39 at x equals 2.73. Students will be able to identify where functions increase and decrease, locate local extrema, find average rate of change, and determine odd and even functions. Use the graph of each function to estimate intervals to the nearest 0.5 unit on which the function is increasing, decreasing, or constant. Support the answer numerically, and we won't do that. We'll say that this increases from -infinity to, let's say, -2.5. Then this function decreases from -2.5 to, how about -0.5, and then increases again from -0.5 to infinity. Over here on this one, this function increases from -infinity to 4, and then when it jumps over to across 4, it decreases from 4 to infinity. Approximate to the nearest hundredth the relative or absolute extrema of that function. State the x values where they occur. Y equals, we're going to clear this out, x to the third plus 2x squared. Well, let's try that again. X to the third plus 2x squared minus 11x minus 12. And let's graph this one. And that minimum maximum are way too high and too low. So window, let's get the y maximum to, let's go with 20, and maybe the minimum to negative 20. And we'll see if that fits. And not quite low enough, but that's okay. We're going to calculate the maximum value. So we're to the left of the maximum value, to the right of the maximum value, and we can just guess right there. We have the point negative 2.69, 12.59, and then we'll get this other point. Second, calculate a minimum, or number 3, and I can say it's between 0, I can just hit the number 0 and the number 3, and I'll guess it's at 2. Another way to do that rather than doing all of that, just holding down the arrow buttons. 1.36, negative 20.74. So this function increases from negative infinity to negative 2.69. Then it decreases from negative 2.69 to 1.36, and then increases again from 1.36 to infinity. Find the average rate of change of each function on the given interval. We need f of 2 minus f of negative 1 over 2 minus negative 1. So let's see, 4 plus 2 is 8 minus 3 is 5, minus 2 minus 3 is negative 1 over 3. So 6 over 3, 2. Determine if each function is odd, even, or neither. This is an even function. And we got to show that f of x is equal to f of negative x. So 3x squared minus 4 is equal to 3 times negative x squared minus 4. And that's equal to 3x squared minus 4. This is an odd function. So f of negative x should equal negative f of x. And so we have 2 times negative x to the third minus 4 times negative x should equal negative 2x to the third minus 4x. Well, this becomes negative, 2x to the third. This becomes positive. Running the negative through, we get negative 2x to the third and then plus 4x. So that's an odd function. Since this is even and x to the first is odd, this is neither. Determine whether each function is continuous to the given x values. Justify using the continuity test. If discontinuous, identify the type of discontinuity as infinite, jump, or removable. This factors into x plus 2 and x minus 1. So those cancel. F of negative 2 does not exist. The limit as x approaches negative 2 of f of x is equal to 1 over negative 2 minus 1, which is negative 1/3. This is a removable discontinuity. This is a hole in the graph. For 1, f of 1, it also does not exist. And the limit as x approaches 1 of f of x, it does not exist either. This is an infinite discontinuity. If we plug 2 in for this x, we get 4 minus 3 is 1. If we plug 2 into this one, we get 4 minus 2 is 2. These are not the same. So the limit as x approaches 2 of f of x does not exist. F of 2 is equal to this one right here because of the equal sign. It equals 2. This is a jump discontinuity. Write each in interval notation. Less than 3, x is less than 3. Negative infinity to 3, union with 8 to infinity. Find each function value. Negative 2 is equal to negative 2. So 4 plus 3, that's 4 plus 3, that's 7. 1 is less than negative 2. No, it's not. 1 is greater than negative 2, so we'll plug it into this one. 1 plus 3, that's 4. And negative 5 is less than negative 2. That's negative 15 minus 1. That's negative 16. State the domain of each. There's no radicals, no denominators, no problems. Negative infinity to infinity. This one, we have x plus 2 times x plus 1. So we have to skip over negative 2 and skip over negative 1. So negative infinity to negative 2, negative 2 to negative 1, negative 1 to infinity. With this one, x squared minus 16 has to be greater than 0. Now this factors into x plus 4, x minus 4 has to be greater than 0. So over here, we have a parabola over here at 4 and over at negative 4, and this is what a parabola looks like. We need to have positive values, negative infinity to negative 4, union with 4 to infinity.